Hey everyone, what's up? Welcome back to Subnet Zero. So, in the previous video, we learned about the entire framework of Ethernet, like network interface card. Let me just zoom in over here just to refresh the diagram. Yeah, you see this pink circle? Instead of pink circle, I've just used a freehand to showcase the private network, okay? Just to recap, we had learned about the network interface card, the whole Ethernet frame over here. Let me just, yeah, the whole Ethernet frame, the payload, the data being converted into binary, what the MAC address is, the frame check sequence, and the whole 9 yards, okay? So in this one, we will understand address resolution protocol or ARP and how does the sender PC is able to locate the correct MAC address, okay? So without further ado, let's jump right in. So to understand address resolution protocol, before we proceed, I want you to get familiarized with this term protocol because we will be seeing this a lot in our later videos. Okay, what does a protocol mean in layperson's term? A protocol means basically a set of rules which everyone has to abide by to make things functional. That is a protocol. Okay. Now, when we are referring to protocol in the terms of computer sense, the protocol basically over here is are a set of rules that network engineers in the going back into history, the OG network engineers, they had made it as such so that all the future devices, okay, they all follow these exact rules. Okay, I'm not going to get into the history of how the network engineers or how the computer engineers they develop this protocol, but essentially this is the mechanisms of it, how it works. Okay, we need to know the protocol, okay, more than understanding how it was formed, if that makes sense. Okay, so in this diagram, yeah, that we referred to earlier in the previous videos, and we are only going to use this as a baseline. Okay, so in this, let's say in this private network, okay, there is PC1. This is the sender PC. Okay, it wants to send a message or data packaged in an Ethernet frame to one specific computer. However, there are like three other computers competing for that. Okay, so how does it work? Let me first use the color blue. Yeah, so imagine PC1 is in a room full of strangers. Okay, PC2, PC3, PC4, they're all strangers to this person. And this PC1 shouts and says, "Hello, entire network. Which one of you has the IP address of 192.168.0.5? Hey, which one of you has that? I want to talk to you specifically." So first what it does, that it will give a shout to everyone. Okay, it will ask all of them together, "Hey, are you the computer with the IP address of 192.168.0.5? Please speak up if you are." PC4 will be like, "Nope, not me." PC3 will also be like, "Nope, not me." PC2 will be like, "Yep, that's me." This is the IP address of 192.168.0.5. It will send an acknowledgement that, "Hey, hi, I'm also 192.168.0.5. That is my IP address. But, however, please note my MAC address. It is 1122334455. Sorry about my drawing. 66. Hey, that is my MAC address. Please note this down as well." So PC1, what it will do is that it will gather all this information. Let me just use a different color. Yeah, it will gather all this. Actually, this is a bad color. Wait. Let me make something more. Let me use green. Yeah, this green. So PC1 will be like, "Okay, yep, gotcha, that's you." So now a connection is formed between, sorry, now a connection is formed between these two computers, okay? And the rest are ignored. Now, after PC1, the sender PC, it has received all this information, that 192.168.0.5 and the MAC address of 112233445566, that it stores in its operating system. So what do I mean by operating system? I'm pretty sure all of you would have used Windows, Linux, iOS, Android on your phones, okay, or on your computers. So this ARP information, this information over here of this PC2 of 192.168.0.5 and 112233445566, this MAC address is stored in its operating system cache. CACHE. Now, what is a cache? Just forgive my drawing. Yeah. What is a cache? A cache is basically like a temporary storage mechanisms within the operating system. so that it doesn't have to do this. Hey, which one of you is 192.168.0.5? Speak up. It doesn't have to do this all the time, okay? It reduces the stress, it reduces the load on this PC, okay? And same mechanisms goes for all other PCs over here as well, okay? So once it's like stored temporarily, so whenever there is like a new data with this IP address to this IP address 192.168.0.5, it automatically says, hey, I already know the MAC address of this one is 112.223.344.5566. I don't have to break my brains over that. So essentially, a familiarity connection is formed. Yeah, makes sense? I hope my funny voice is helping make things more interesting and easy. So, yeah, if you look at the address resolution, it is 3 steps, okay? First, the sender PC shouts to the whole network that, asking the specific PC to speak up with who it wants to talk to. Like, essentially, whenever you are in a room full of strangers and you'll be like, I want to talk to John. Can someone named John speak up? And let's say if there is like John or Raj or let me think of a third name, Peter, okay? If there's John or Raj or Peter, so John will be like, hey, I'm John. So finally, a connection is formed, and next time when you walk into the same room, you recognize who John is, okay? So yeah, so the receiving PC essentially says, hey, that's me. After that, a connection is formed, and the information is stored in sender's PC operating system cache. Okay, again, another word familiarized with, okay? When we are referring to, again, PC is personal computer, OS is operating system, and cache is the temporary storage mechanism, okay? Please familiarize yourself with these terms because we are going to come across through this a lot, and you should not like look at the terms and be confused, like, what is she talking about, okay? So this is, in a nutshell, how this works. So I hope this, so this is basically what it is. Nothing as complex, yeah? And again, little concepts we'll keep building up, and after that, you'll understand how it all gets pieced together, okay? So I hope this video was fun so far. I hope my funny voice was fun so far. And if it did, consider liking, subscribing, and sharing this with anyone who might find this useful. Please hit the bell because you only scratch the surface. We will be going through further videos and further playlists. And you have no idea how deep the rabbit hole goes. But I promise you it's going to be fun each time, okay? So thanks for watching and I'll see you in the next one. Bye.